Hello, it's Duncan. Our 10-pin bowling domain model has lots of types to represent different game states. A type combines a set of values and the allowed operations on those values. And in Kotlin we can define those operations as either methods or functions. Methods are part of the type inside the class definition, whereas functions are external. Where we want a close coupling between an external function and a type, we can define extension functions, which are called like methods but defined outside the class. How do we choose between a method and an extension function? Stay tuned for my rules of thumb. Before we get on with things, there's an ergonomic issue I want to address. And we see that in both these tests here, where we start with game and then game 2 and game 3. This one has game 2, game 3. And having to invent new variable names is a consequence of handing back a different game object every time. Now, a different game object every time is kind of the point of this, to make illegal states unrepresentable, but it does cause us a problem here. So let's see what we can do with that. What I really want to be able to do is just reuse this variable. And in fact, of course, I can reuse this variable if it actually is a variable. So we could say var. And then in here, we could say that this was the same variable. So this would be game, like that. And then this variable assigned to the different game would be a playable game. And now we could just say here, this is game again. So that would simplify everything, and we wouldn't have to keep on remembering to update the variable name here as well. There we go. So now we have a single variable that we reassign to every time we step the game on. And we step the game on with roll. Now that passes the tests, but we can make it a bit smaller as well by casting in here. So we could say this is game as playable game, and then we could take out that. Good. Now we might like to do the same thing here. So we'd say this is as playable game, and then remove that. But there's an issue here that because we've said that game is a game here, we can't call current player on it. Now I think that's sort of a failure of flow typing, because if this has succeeded here, we know that game is a playable game. And in fact, if we just take this cast out of here and say game as playable game, you'll notice that compiles. So that's a little bit weird, but we can make everything symmetric by just declaring the variable here and then assigning to it here as game, like that. A little bit unsatisfactory, but works. So we can do the same thing down here. We can say that we've got a var of line, whose base type is line, assigned to it the first time as line is playable line. We don't need to cast that because we're actually just calling constructor here. But here we can say that line is our original line roll as playable line. Don't need that. And here I can say line is that line again. And then I think it makes sense to assert the final state as one thing on its own. So that's line is completed line. Good. Now back up the top of the file, we had this disable test, and it's disabled because we can only handle one player, because there's to do here, handle more than one player. And we can only handle one player because we didn't know how to work out which was the current line. So let's see if we can get ourselves running there. First of all, we'll structure this like we were before. So we'll make this var game. We'll say game is a game of Fred and Barney as a playable game. So we don't need that assertion. And we want the current player to be Fred. And then here, if we were to say game roll pin count 1 is a playable game, and we would still expect the current player to be Fred. And then if we roll another roll, then we would expect Barney to be the current player because Fred had rolled twice. Okay, delete those and reinstate this test to see that it fails with our not implemented. Okay, so how do we work out which is the current line? Given that we have a list of lines and those lines may be playable and the frames inside them may be playable and so on. Well, one way we could do it would be to pass that as state between the playable games. So when we first create a playable game, the first line is playable, And then when we roll here, we'd work out which is the current line and then pass it into the playable game here. However, it'd be nice to just do this from the data. And so let's think about that. What I'm going to do is I'm going to make this into a block body, so we've got a bit of space. Now, one of the things we have to consider is that an individual line doesn't know whether it is the playable one. It knows whether it's playable, but it's only the playable line if it's the one that's had least balls thrown down it, or at least number of frames played. So what we need to do is we need to find the index of the first playable frame in each line. Move this over here a bit so we've got some space, and we'll say that that is val indices of first playable frame. Now that is our lines map for every line, and we're going to say that this is a line and we're looking for the line's frames, index of first, it is playable frame. So what will that give us? Well, it's a list of ints. So the playable line is going to have the minimum of those ints. So we can say val index of first playable frame is the indices of first playable frames min. And now as more than one line can have the same index of its playable frame, we are looking for the index of first playable line is the indices of the first playable frame, index of first, it is the index of the first playable frame. And then we should be able to return lines at that index. And that ought to be a playable line. Now, none of this code proves that, but it would be an error. So I think this is, say, error. We don't know why that might go wrong, but let's say this is a programmer error. Our logic was wrong if that isn't a playable line. Okay then, let's try running that. That's good. I will pretend that I didn't have to think about this quite hard, but let's go and add in the test to show that it works everywhere. So here we're still a playable game and Barney is the player. So now let's roll again for Barney. Barney will roll a 3, and now if we roll a 4 as Barney, then that should be the end of the game, so game should be completed game. Run that. And that fails. Where does it fail? Well, apparently our game isn't completed. That's interesting. Oh, I'm an idiot. This is a 10 frame game. Let's just put frame count is 1 in there. Run again. Oh, and now we're getting our programmer error. That's interesting. When is that happening? It's on 32, which is here. So that's when we switched over to Barney. The current player here, we're deriving from the current line. So I think we should be able to set a breakpoint here and debug this one to see what's going on there. Okay, there we are. And now let's set a breakpoint here so we can see the state of everything when we run on. There we go. So the indices of the first playable frames are, here we go, look, -1. Let's have a look at our code. So we are saying index of first here, but that returns -1 if the list doesn't contain an element. So what's happening is that once a line is completed, that is to say there are no playable frames, the indices of the first playable frame for that is going to be set to -1, but we're then taking the minimum, and so that's -1. So the minimum is now -1, and that means we're selecting the first line when we find the index of that -1 in our list of indices, but we know the first line isn't playable anymore. That's the reason we didn't find a playable frame in it. Okay, two things we can do. We can use a very big number instead of -1 here, or we can just filter out all the -1s. And I think probably that's the easiest thing to do. So let's stop the debugger, put everything back to normal, and in fact I think there's a solution which is a bit of both, which is to say not min, but min by in here. So that takes a block, and it in here is the index, so we can say if it is -1, then we want to put it right off the end, and our way of saying that is int.maxValue. Otherwise, we want to use the value of it. Let's see how that does for us. Phew. I think I'm only running one test though. Let's run all of them. And we're still good. Now, I'm really an object-oriented programmer at heart. And so when I see something this complicated, I want to move some of the complication to our collaborators. But the fact is, here I don't think we can. None of these operations make any sense to individual lines. They only make sense in the context of a playable game. But I suppose we can at least move this out of our face as the first thing we see in a playable game. So let's cut that out of there. This is public, and we'll move this private thing down the bottom so we're not so offended by it. I'm tempted to check in at this point, but this is also complicated enough that I'm suspicious about it. So I think maybe we should play a game with more than one frame each to check that we go back up to the top. So let's go here and we'll say we'll play 2 frames each. Now we won't be a completed game after Barney. So here we'll say as playable game. We'll check that we go back to Fred at that point. And now I think maybe we can just roll some more things. So we'll say, so we'll take that. So that will be Fred's roll. We'll say 5. Another roll for Fred as 6. That should make Barney player. Barney can roll 7 and an 8, which would finish the game. Is that true? Well, that's pleasing. That feels like a good place to check in with implement current line. Splendid. Okay then, before we go on, let's have a look at our tests. We've got a test at the top here, which is that if we don't have any players, then the game isn't playable. Well, that's just documentation of a corner case, but I think it's worth keeping. A game with players is playable. Well, that shows that 1 or 2 players both make a playable game. I think it's useful to have at least 2 examples, but maybe we should make these symmetric by at least inlining that. Play a game then. This is made tractable by our ability to create a game with fewer than our 10 frames. Otherwise we'd be scrolling down a long way. Play a game with just 1 player and 1 frame. I'm not sure this is earning its keep. Don't think it's telling us anything really that we're not being told up here, except conceivably that our algorithm for current line works in the case of only 1 player. Maybe that's worthwhile, so let's leave it here for now. We then have a test of what happens with a line, and that really is a unit test. It's testing just a playable line. We used it to get line roll working, but I think line roll is now completely tested, in fact, by game roll. There might be corner cases that we want to test individually, but I don't think this is one, so I'm just going to delete this. Now what I want to do is play more complicated games, ones where we've got strikes, for example. We could make assertions that look at the game and look at its lines and look at the frames within a line, but some sort of view more akin to an actual bowling scorecard would make the test a lot easier to comprehend. So I think we're going to write ourselves a test for render scorecard. Okay then, as usual, we'll start off with an empty game. So we'll say empty game is a game with no players. What should that look like? Well, I think probably just an empty string. So we say expect that empty game to scorecard is equal to an empty string. Now, let's bring this into existence, and the question is where? So far, all of our operations have been methods. They've been directly associated with the classes over here. But rendering, well, that's a bit more arbitrary. I think I'd like to separate that from the real game mechanics. So I'm going to create an extension function here on game. So that's like that. And then IntelliJ created that in the tests, and I suppose that's probably as good a place as any for now. But we know that it wants to return a string, and we can make this test pass by saying return an empty string. Good. Right then, what about a non-empty game? Let's just inline that. Let's create a game with our 2 players. So that's Fred and Barney. And we will have 1 frame to make our life easy. How do we want that to render? Well, I suppose we want 1 text line for each game line. So let's make this a triple quoted string. Is that all of them? 1, 2, 3, yes. And if we put this in here, IntelliJ helpfully trims the indent for us. So I think we'd like a line to start with Fred and one for Barney. And actually this begs the question of what would a game with a frame count of 0 look like? You know, I'm not sure we've even tested that. So I'm going to put that as 0. And then just to find out, I'm going to go back up here and say a game with no players isn't playable, but also a game with no frames. So if we create a game with Fred and Barney, but a frame count of 0, is that a completed game? To run this test on its own and find out. Oh, it isn't. Interesting. We've actually hit one of our requires that's there in order to ensure that we have consistency. So where's that? Ah, okay, a playable line must be not empty. But I suppose up here, where is it? Up here, player names wasn't empty. So we then created a playable game with a frame count of 0. That led to 0 frames being passed into here and a playable line of empty frames. It's interesting that we're still finding out things about the model that we built through adding tests and finding edge cases. But what should we do about this? If we had in our type system the idea of a number that had to be 1 or greater, then we can use that as the frame count here. But we don't, and it would complicate things quite a bit. In the place where we're just setting up a game and maybe don't need quite so much type safety, we can improve our error message by checking that this frame count is 1 or greater, although that is a little bit hard because we can't create a block here. We have to call the constructor directly. We might be able to introduce a scope with a run, so we could say run this block of code. That is, that's calling the run extension method. We don't want that one. We want this one, but I don't know how to differentiate between the two. What's the error message? It is cannot access run before the instance has been initialized. That's a bit irritating. So the compiler has decided that I want to call this one, but I can't because I'm accessing this, rather than I want to call this one, which I could call, and it's syntactically identical. Maybe just unit.run? Oh, interesting. That looks promising, if slightly confusing, and gives us somewhere to say in here, require frame count is greater than or equal to 1, with a message of cannot construct a playable game with $frame count frames. See whether that improves the error message. And it does. So having done that though, where can we fix things? And I think the answer is up in game. So at the moment we're saying PlayerName is empty, we have a completed game. But if PlayerName isn't empty, then we have the case where frame count equals 0. What can we do in that case? Well, we can return a completed game. Now this is going to have as many completed lines as it actually has players. So that's going to be playernames.map. And for each player name, we want to return a completed line with a player name from the player name, which is it, and a list of completed frames, which is going to be empty. So I think we can pass empty list into that. So if I run that, that's only one test, but let's make sure we run them all. So apart from our render scorecard, we're now passing, and we patched this hole here where our type system allowed us to pass a 0 frame count, but we weren't doing the right thing. So let's go down and render that thing. Here we are. We've got a game with no frames and just Fred and Barney. What should that look like? We know that should just have Fred and Barney on a line each. How can we make this pass and this pass at the same time? Well, I think the answer is that we'll say it's this, the game, lines, join to string, with a line separator as our joiner. And each line at the moment is just going to be the line dot PlayerName value. Does that work? It does. Good. Go back here and remove the type from that. And I think we might be in the place where we admit that PlayerName is not a type that's helping. Let's go and remind ourselves it is here, and we are using it as part of a completed line, well in fact as part of a line. So I think we just go here and say if this was string, we'd have to fix that in line there and playable line, and now we wouldn't need to have done that, so we can take that out. The current player, we can remove the value from there. Anything else? We don't need to create a player name here, and we don't have to extract the value there. That's good, and if we're right now, then player name in here as a type should be unused and is. Okay, so we'll take that and put it down with our unused types so that we remember when we come to do a retrospective that we thought it was going to be useful, but it hasn't been. Okay then, focusing now just on the rendering, let's create ourselves a game with one frame for each participant, so that will be frame count of 1. Now, what will we like in here? What we're looking for is a format that's easily paused by humans, that is, say, me, when I'm trying to work out whether the game is right, and easily written by the computer. What I think might work is if we put in spaces where the pinfall should be, so that's like that, and the same for Barney. And now something for the cumulative score. Well, we're not actually calculating that at the moment. We've been concentrating on the game state, but it would be nice to prepare for that. So I think I'm just going to put in zeros where the score should be. And we know in a game of bowling that can't go above 300, so I'm going to put in 3 zeros. And the reason for this is that if I don't put in the score now, I'm going to end up doing a lot of reformatting when we do finally introduce the score. We'll keep an eye on this format to check that it keeps working for us. But at the moment, we can probably get this to pass by saying that the thing we want to render for each line is the line's player name plus, well, I guess we can just hard-code this string. So that is base and that and that and that. Am I right? Oh dear, let's have a look. Ah yes, of course, I'm rendering this whether or not we have any frames. What I really want to do is render this for each frame. So I think in this case we're going to say line.frames.map, and we'll put in that and see whether it works. Still not. Sigh. And now the problem is that this thing is the rendering of an empty list. So in fact, I think what we need to do is say join to string with a space, one of those for each frame. Is that right? Very nearly. Well, at least you can tell that I haven't rehearsed this bit. I think I'm going to get us passing by deleting this for now and coming back to it when we've refactored. Okay. Let's tidy this a bit by making this expression here a function, which is to scorecard for a line. And we'll make line our receiver. Now then, in here, this is our frame. And this is what we want a frame to be rendered as. So let's make a method out of that, which is going to be to scorecard. And now IntelliJ is complaining because it doesn't know that really we wanted this to be frame to scorecard, like that. Oh, we've lost that work. Try again. So we're going to say that this is a method that we're going to call foo, that really this wants to be an extension on frame, so that here this is frame.foo, and now this is to scorecard, or right. Now I think we can put the space back in here if we say that the thing we want to join to string is a list of the player name plus the frames mapped to it.to scorecard, and we want to take that entire thing and join it to a string with a separator of a space. Is that right? Good. Okay, I think I'm going to divide this test into two. One is render pathological scorecards. So that's the case of those two. But also now we want a test fun render scorecard. And now let's work our way through a game. So we're going to do what we had to do before, which is to say val game, which is a game, and we just declare it up front. Now we say that that game starts as this game here with Fred and Barney and a frame count of 1. And that we know is going to render like that. Run that. Good. Now we'll step the game on. So game equals game.roll, and we can't call that without saying here that it's as playable game. And we're going to roll a pin count of 1. And we needed to have said val. Okay, what should that look like? Well, the answer is it needs a 1 in here. It won't have a course, as we expect, but now we can work out what we need to put in here and how. So let's remind ourselves what frame looks like. And the answer is it's a thing with a score in it, but this top level frame doesn't actually have any pin counts. We have to go down into the individual types of frames. Now we could add a method to frame this to scorecard, but if we do, it's going to be tied to this particular way of rendering rather than any other ways. So instead what we're going to do is we know this is a frame, but we are going to select the different subtypes of frame with a when. So we're going to say that this is when this, and at the moment this is our else. Okay, at the very beginning of a game, all of our frames are unplayed frames. So our base case here is unplayed frame, and we basically want to render an unplayed frame like that. Once Fred has rolled once, we have an in progress frame. So this is in progress frame. Now how do we want that to render? Well, pretty much the same, except that we now want the first pin count of an in progress frame. Now, as it happens, that's roll 1, and we can get that from an in progress frame. So I think we should be able to say that this is $roll1. And to keep us honest, we will put a to do in here, reminding us the type that we need. So this is frame of type $this class. Does that work? No. And it doesn't work because pin count is rendering as this thing here. Now we can either change the toString on pin count to just render the number, or we can say this is roll1.value. I'm going to try that first. That gets us going, good. And now we can step through our game in order to add another type of frame. So if Fred rolls a 2, you could only do that if this is a playable game, and in that case we'd expect a 2 in there. That should be caught by our to do, and is, look, and this is a normal completed frame. So let's remember that. Go in here and say is normal completed frame. Inside this block, note this color here that says we know this is a in progress frame, and so inside this one we know we are going to be a normal completed frame. So we can put that in there and then copy that into there as roll2 value, where that roll2 is the roll2 on a normal completed frame. Run that, and we're still good. And now I think we're in a position to test both the rendering of a strike and what we do with a strike in one go. So we can say that Barney now, if this is a playable game, if Barney rolls a 10, then our scorecard should look like an X in there, and this shouldn't be a playable game, this should be a completed game. Well, we'll find out about the completed game first, I suppose. It looks like it was a completed game. That's good because we got through here into this rendering. So now we just need to render a strike. So we'll take that and say in here is strike. Then we want to render that. Again, the cumulative score we'll come back to. Run that. And we are actually getting somewhere. Are there any other types of frames we need to worry about? Well, let's go to see frame. And this is the point where we discover we didn't make frame a sealed interface. So if we go back and try and take this else out, this when is not exhaustive because we've covered unplayed frame, in progress frame, normal, completed frame, and strike, but anyone can come along and create a new type of frame at any time. However, if we make this sealed and go back, now at this point we can ask IntelliJ to fill in what we haven't covered. So now the remaining are a completed frame and a playable frame. That though is a bit of a bum steer because completed frame and playable frame here are only sub-interfaces of frame there to allow us to ask the question, can we roll on it or not? So again, if we made these sealed to say that all of the subtypes of those are in this file, like that, now we can go back and we discover that we don't actually need those. So unplayed frame, in progress frame, normal completed frame, and strike are all of the types of frames that we have to worry about. Splendid. So now we've answered the question that I posed at the beginning of the last episode, which is, would the fact that frame isn't a sealed interface ever become a problem? And as we've seen here, sealed types are useful when we want to add operations on the outside of the type. So we could have added toScoreboard on frame, but if we wanted to render a frame as XML or JSON or all these other things, we'd end up polluting this file with all those different format types, whereas a single extension function can do the job if we've defined a sealed type. I think we have one last rendering thing we should address before we go, and that's a spare. If we extend this game a little, we can add ourselves one of those. So if I say frame count is 2, then this will be a playable game here, and we'll expect empty frames on the end of these. So that should look like that, and that, and that, and that, that, and that. That. Is that true? Phew. And now let's have Fred roll a spare. So we'll say Fred will roll a 9, giving us a game that looks like this. Good. And now he'll roll a 1, and a spare is marked with a slash in there. We shouldn't see that because we haven't done something about it. And now we'll come here and we'll say, let's make this thing a special method or extension on normal completed frame. So this can be normal completed frame to scorecard. And now this second one here, we want to render as a slash if it's a spare. So in here we can say if is spare, it's a slash, else roll to value. Now, is spare isn't defined, and again we have a choice of whether to make this a member property or an extension property. We're only actually using it in the rendering here, but I think is spare is actually fundamental to a normal completed frame. So that was to be a member property. And it's going to go on to normal completed frame. And is spare, we get that by asking roll1.value plus roll2.value equals 10. If we go back here now, you can see that that compiles, and if we run it, we are good. One last thing, let's have Barney score a 0, which would be a dash. So we'll take this, we'll say Barney rolls a 0, then the scorecard should be a dash in there, and we can achieve that. Well, we've got roll 1 value, and so on here. I think this is a case where we decided to get the value out of here, but if we'd gone to pin count and said that it's toString, returns if my value equals 0, a dash, else value toString, fix that into an expression body with a when, and now going back here, we should just be able to take out that, and that, and that. Splendid. Well, I think that's enough progress. I don't want to lose it. So let's check that in with add scorecard. And I think there was some behavior in there as well. Let's have a look at our code analysis now. We have some unused things. Where are they? Well, that's interesting, but I guess we'll be using it when we actually implement scoring. Player name, player and foul. We're leaving in there for when we come back and see how well we did on guessing the types. And this case here, I'm pretty sure that's what we want, but maybe we should suppress it for this function. And maybe amend commit that. Looking back at our domain model, once again, we haven't had to change it much in light of the information that we've gained by writing tests. We did find this pathological place if we pass in an empty frame count. That wouldn't have happened if we'd had a natural type for integers greater than 0. But often, especially when we're creating these things like that are a bit more overhead than we want. Unit run was a bit of a wrinkle. I don't think I've ever had to do that before. And looking down, well, a lot of our work today was this current line. I'm not sure how happy I am with it, but it does appear to work. Maybe you could find something sweeter and let me know in the comments. And finally, we discovered that we needed to make frame into a sealed interface if we were to add operations externally that depended on the concrete type. Well, I hope you're enjoying this little series. If you are, then please like and subscribe. I think there's probably only one episode left that will cover scoring the game. I don't know quite how to do that yet, whether to keep a running total and update it as we go along, to calculate as we render, or quite what, to be honest. If you'd like to find out, then please join me next week, when once again I'll sign off by suggesting you buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.